Okay, welcome to the last video for week 11. Still talking about completing the square because it's a very important concept. Everything is important in math, right? So I'm just going to bring it in a little closer, and we're going to solve each quadratic equation by completing the square. The easiest thing, remember, we need to focus on these first two terms. So just trying to make sure we are not blurry here. We're going to get x squared minus 6x. This 7 right here, we're going to move to the other side, so it's going to equal negative 7. We open up that space to figure out what it is we're going to add. Whatever this number is, we're going to take half of it. So 6 divided by 2 is 3, and 3 squared. Okay, you take half of that number squared. Half of b squared. B is the middle term. So whatever this term is, take half. Half of 6 is 3. 3 squared is 9. And we're going to add 9 to this side, and whatever you do to one side of the equation, you have to do to the other. Now, once you have completed the square here, it allows us to write the square this way. See, it's squared x half. What was the half number? The half number is always going to go here, and since this is a minus, we're going to put a minus here. Equals negative 7 plus 9 is 2. So now we're going to go ahead and solve this equation. Wait. Write your answers, then explain how you can determine how many solutions. We don't have to solve it, we just have to, write your answer in exact form. So we're going to, how many solutions is this going to have? I know there's a lot of stuff going on in my brain right now. So write your answers in exact form and explain how you can determine if it has, how many solutions a quadratic equation has once it's written in perfect square form. So once it's written here, I know that this number is a 2 and it's a positive number. Remember, the positive number, it's going to have 2 solutions. Not because the answer is 2, there's 2 solutions, but because it's a positive number. Positive number. But if I go to solve this, to get rid of this square, I have to square both sides, and I end up getting x minus 3 equals plus or minus the square root of 2. If I add 3 to both sides, I'm going to get x equals 3 plus or minus the square root of 2. So that's like saying 3 plus radical 2 and 3 minus radical 2. This is how we want our answers. I actually like it in this method, in this format right here. Blah, let's try another problem. Okay. Well, I want to focus on these two right here. So it's going to be p squared plus 2p. And then what is half of this number is 1. Oops, 1. 1 squared is 1. So we know we're going to add 1. But check this out. There already is a 1 there. If you don't remember, if you don't notice that and you move the 1 to the other side, that's okay. We add 1 here. If this was a negative 1, you'd add 1 here and you'd end up with 0 again. But I don't have to change this problem at all because it's already a perfect square. I can write this in perfect square format by going p plus, and remember my half, whatever the half number is, was going to go what's in the parentheses, equals 0. Because this is set equal to 0, that should be a reminder that there's one solution. One solution. And let's solve for that solution. We're going to get p plus 1 equals 0. Subtract 1, you get p equals negative 1. We're going to have to be practicing this, I can tell already, because this is a complicated topic. Let's do this one. I want to write it in perfect square notation. Currently, it's in what's called standard form. This is standard form when you have just something squared plus something plus a plain number equals 0. But when we write in perfect square, we're going to focus on these numbers. We're going to get k squared minus 4k. I'm going to subtract 9 from both sides to open up that space. And this is what I want to figure out what I have to add. To take half of this number, half of that number is 2. And then when I square it, I'm going to add 2 squared is 4. So I add 4 to both sides. And now I can write it as a perfect square. K, 2 squared, does it go a plus 2 or a minus 2? Well, because there's a minus here, I'm going to put a minus here, equals. And negative 9 plus 4 is negative 5. Well, how many solutions are there? Well, remember, if that's a negative number, this is a negative number, that should tell you that there's no solutions. There's no solutions for that, because if I were to go try to solve it and I take the square root of both sides, there's no number that I can take the square root of -5. There's no solution, right? No real solution for this, so we just leave it like that. Okay, so everything we've been doing so far, notice our b value, this is a even number 6, this is an even number 2, this is an even number 4. Very easy to take half of. Let's move on to this next problem, and you can see that our middle number is a 5. Well, that's not easy to take half of. Well, it's 2.5, and notice they have x plus 2.5, x plus 2.5. So let's do this. How many unit tiles are missing? Well, let's see. How many unit tiles are missing? I'm going to draw this in. Here's 1, 2, 3, 4. These are halves, so together this is 5, together this is 6, and then that's a half. So it's missing 6.5. Oh, probably can't see it. It's missing 6.5 tiles. So we're gonna do 6.5 tiles here. 6.5 tiles. Help Jessica finish her problem using the perfect square formation. Well, since you don't have algebra tiles at home, we're just going to keep doing the algebraic method, which I love more anyway. And we're going to go x squared plus 5x plus 2 equals 0. And remember, we're just going to focus on this part right here. X squared plus 5x. Move this 2 over to the other side, -2. We're going to open over that space. And what is half of 5? That's 5 divided by 2, which is 2.5, but I'm just going to write it as 5 halves. That's the half number. And then when we square it, we get 5 squared is 25, 2 squared is 4. We get 25 fourths. So we're going to add 25 fourths to both sides. Yes, now we're dealing with an odd number. We're going to have to deal with our fractions. Okay, so I can still write this as x plus, why do I need to know that half number? Because that half number is what's going to go into the parentheses when you set this up, equals, well, what does 25 fourths plus -2 equal? Well, let's see, -2 over 1 equals how many fourths? Let's find a common denominator. 1 times 4 is 4, -2 times 4 is -8. So really, this is saying -8 fourths plus 25 fourths. My common denominator is 4, -8 plus 25 is 17. Okay, so that is our equation right here. Writing the perfect square form of her equation. This is the perfect square form. It didn't say to solve it. It just says write it in perfect square form. And that's what we have done. Let's look at the next page. Okay, so compare the standard form of each equation to the perfect square form. So this is the standard form, and this is the perfect square form. When a quadratic is in standard form and it's changed to the perfect square form, how can you predict what will be in the parentheses? Oh, well, I've already been talking about that. So x squared minus 6x plus 7. Remember what goes in the parentheses? You're going to take that half number. We're going to use half of b inside parentheses. Okay. So if in this problem it would be, let's just do it. X squared minus 6x plus 7. Here's what I need to worry about. I'm going to move this over to the other side. So you get x squared minus 6x plus something equals, subtract 7 from both sides. Well, what is that half number? Half of number is 3. 3 squared is 9. But then when you write the parentheses, remember it's x plus 3 squared. And if I add 9 on this side, I have to add 9 on that side. This is the same problem we already did. Equals 2. But the half of b is what goes inside the parentheses. So let's look at that pattern to write the perfect square of this. So we're going to look at this problem right here. Okay, good, it's a little less blurry. We only want to focus on these two guys. W squared plus 28W equals, let's move that 52 to the other side. What is half of 28? It's 14. So 14 squared, okay, is what I'm going to add there. So I'm going to get 14 squared is 196. So I'm going to add 196 to both sides. So here we're going to get W plus 14 squared. That's my perfect square. I got that 14 because it's half of 28 equals. And what is 196 minus 52? Let's see, 144. Okay. And now solve it. We're going to take the square root of both sides. And we're going to get W plus 14 equals plus or minus, the square root of 144 is 12. So I'm going to get W equals, subtract 14 from both sides, negative 14 plus or minus 12. So I have negative 14 plus 12, negative 14 minus 12. So my answers are negative 2 and negative 28. Those are my numbers. And what that means, let's go back and think about that parabola. What that means is that parabola is going to cross the x-axis at negative 2 and at negative 28. Okay? I want you guys to practice, because we've done a lot of practice. We have part B, C, D, E, and then these problems down here. There's 5 problems to practice on your own. This is what you're going to take a picture of and submit for week 11. And remember to hop in on Zoom and ask for help if you don't know how to do that. And I will do them on Zoom. The benefit of showing up to Zoom is that you get the one-on-one help, or the 8-on-1 or the 10-on-1, however many students. I will point out that this one, the 17, is already moved over. So when you're just focusing on the first 2 problems, think about what is half of this number squared to add to both sides. All right, have a great day. I will see you on Zoom.